Let's delve a little into energy, work and power. For an object of mass m moving with velocity v, the kinetic energy we know equals 1/2 mv squared, and this is energy due to its motion. So momentum is mv. And now here's an example. A brick initially at rest is raised by a force averaging 40 newtons to a height of 5 meters above the ground, where it is left stationary. How much work is done by the force? Or the solution: work done by the force raising the block is 40 multiplied by 5 equals 20 joules, because that's our work done. And another example: a train is on a level ground and subject to a resisting force from the brakes and air resistance of 250 kilonewtons for a distance of 5 kilometers. How much kinetic energy does it lose? Well, forward force equals minus 250,000 newtons. So the work done minus 250,000 newtons multiplied by 5,000 equals 1250 followed by 60 joules, and hence that again in joules of kinetic energy. I really don't want to say all those zeros. Of kinetic energy gained. So the positive of this is the amount of kinetic energy lost, so the train slows down. Now here's an example of a car of mass m kilogram is travelling at u meters per second when the driver applies a constant driving force of f newtons. The ground is level and the road is straight, and air resistance is ignored. The speed increases to v meters per second in a period of t seconds over a distance 5 meters. Find the relationship between F, S, M, U and V. Solution: Newton's law, F equals ma. A equals F over m. F is a constant of acceleration, using the constant of acceleration which we derived in another lecture, and plugging these values in, we get F of S equals this term. Now the work done is the final kinetic energy minus the initial kinetic energy, and this is how we define the work done. An example: a combined mass of a person and bicycle is 65 kilogram. A person accelerates from rest to 8 meters per second in 80 meters along a horizontal road. First, we calculate work done by a net force and accelerating the cyclist and bicycle. And secondly, we will calculate net force, assuming force is constant. Answer: the first answer, the work done by the net force, like what we've just said above, is the final kinetic energy minus the initial kinetic energy. So in more of a mathematical form here, and once plugging in the values, we get this 2080 joules. So the work done, Fs, equals the force multiplied by 80. So 80F equals 2080, hence F equals 26. So the net force is 26 newtons. Please do like and subscribe. I've got plenty more to come.